So I'm going to talk about what immunohistochemistry is, but first let me break it down to you. Immuno is antigen-antibody based, histo is tissue-based, chemistry is the reaction. It is a favorite tool amongst clinicians to help diagnose a range of diseases by identifying abnormal cells, such as those in cancer. In a nutshell, immunohistochemistry uses antibodies to detect proteins that are specific to or have altered expression in abnormal cells within a tissue section. It can also be used as a predictor for treatment outcome.
Now we're going to speak about the steps of immunohistochemistry. The first step is fixation. This is a very important step as it maintains tissue structure and retains antigenicity by using formalin fixed and paraffin embedded method. The second step is antigen retrieval. We use antigen retrieval agents to improve antigen expression of the samples by breaking down formalin-induced antigen cross-linking, re-exposing epitopes on the antigen to antibody binding. Heat and enzyme retrieval are both employed, with heat-induced epitope retrieval now being the most commonly used. In simple terms, heat-induced epitope retrieval is heating the slide in a buffer at pH 6 or pH 9 using microwave or a pressure cooker. The third step is blocking. There are two main factors to consider. The first factor, you want to block or inactivate endogenous enzymes in the tissue that can activate substrate that might be used later in visualizing antibody binding. For example, endogenous peroxidase and alkaline phosphatase. The other is to be aware of endogenous antibodies. For example, those on surface of B lymphocyte in immune tissue. Secondary antibodies may cross-react with these, leading to high background staining in your sample.
Fourth step, antibody labeling and visualization. Now that you've done the entire preparation, it's time for a pretty picture. With immunohistochemistry, staining can be set up in either of two ways, either as a direct labeling or indirect assay. With the indirect detection, you use a secondary antibody with a covalently attached label. The secondary antibody will bind to the primary antibody during the staining process, while direct detection is a lot simpler and quicker. As the label is attached via a covalent bond directly to the primary antibody, once you've labeled your sample, it's time for visualization. If you've gone for a fluorescent label, you need to view your samples directly under a fluorescent microscope. But remember, to use the appropriate examination wavelength and filter sets based on the fluorophore you've used. However, if you've opted for an enzyme label such as horseradish peroxide, a further incubation is required. With the appropriate substrate, in this case, the enzyme acts on the substrate to produce an insoluble colored component that is deposited at the site of antibody binding.